persevere through difficult practices. Jai Ganit! Thank you.
Welcome to DSC News. Here are today's top math headlines. Hyderabad-based mathematical physicist Kumar Eswaran has claimed that he has found proof for Riemann hypothesis, the famous mathematical problem that has been unsolved for 161 years. First posited by Bernard Riemann in 1859, the Riemann hypothesis is one of the 7 unsolved Millennium Prizes from the Clay Mathematics Institute of Cambridge and worth $1 million to the person who solves it. This groom could have never imagined that flunking a simple math test would make his marriage plans go awry. The groom, all decked up, reached the wedding hall on Saturday evening with his Bharat, but the bride, who was suspicious of his educational qualification, asked him to recite Table of Two before the garlands could be exchanged. The groom failed to recite the table and the marriage was called off. If we had to choose between the accuracy of a human mind and a computer, most of us would bet on technology to give us the right answer every time. However, when it comes to logic, computers are a bit behind. You will agree with us when you see this latest viral picture on Twitter that has left everyone scratching their heads. Designers of machine translation tools still mostly rely on dictionaries to make a foreign language understandable. But now there's a new way. Numbers. Facebook researchers say rendering words into figures and exploiting mathematical similarities between languages is a promising avenue. Powerful automatic translation is a big priority for the internet giants. After teaching unprivileged students in Bihar and neighboring states to crack joint entrance exam for the admission of IITs, NITs and other prominent engineering colleges, Super 30 PM mathematician Anand Kumar is all set to teach mathematics to Japanese students as he joins hands with a Japanese edtech company. This week, a team from a university in Switzerland announced that they have calculated the decimal digits of a number to record 62.8 trillion places. The calculation took 108 days and 9 hours, making it over 3 times faster than the calculation that gave us the last record, which had calculated the digits of a mere 50 trillion places. Neena Gupta, mathematician and a professor at Indian Statistical Institute in Kolkata, has been awarded the Ramanujan Prize 2021. Ramanujan Prize was first awarded in 2005. It is given to researchers less than 45 years of age from developing countries in the field of mathematics. Meena from Kolkata received this mathematics.
Thank you for the wonderful prayer, the unique pledge, and the news. Indian mathematics emerged in the Indian subcontinent at around 1200 BCE. In the classical period of Indian mathematics, important contributions were made by scholars like Aryabhatta, Brahmagupta, and Ramanujan. Let us now take you through the journey of mathematics in India.
क्या गणित
विद्वान गणित के विद्वान
मैथमेटिक्स मैथमेटिशियंस अरे भागो
अरे अरे तम्मुडू what is it making you run
लो कर लो बात she was just talking about mathematics विद्वान and you expect your little brother to sit down and listen to you talk about maths your भोला भाला brother चलो चलो भागो
अरे रुक 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 don't leave as there's nothing to worry about. You're creating such a fuss about math. Do you know what it was regarded as?
What?
यथा शिखा मयूराणां नागानां शास्त्राणाम् गणितं मूर्धनि स्थितम्.
It means just as a crest on the heads of the peacocks and gems on the hoods of the snakes, so is Ganita at the top of sciences.
Wah, Akka, wah. It's so nice to hear such things from you. But
But, on hearing mathematics, I get butterflies in my stomach.
Arey pagle, sun to sahi. You're so biased. Your fears don't have any logical base.
exactly. Maybe Akka is right. We have only shut our minds.
Yes. And the only way to get rid of your fear of math is to open those minds.
Tandana.
तंदाना? अब ये तंदाना क्या है?
Tandana, as you say. But Akka, I still feel a mystery story would be much better.
Tamudu, the story of Indian mathematics is full of mysteries.
That's interesting.
Then let's start.
But Akka, हम अपना ट्यून अल्टर के लिए तो बेहतर नहीं होगा?
Granted, बाबा. आइए गणित के आनंद सागर में विहार करने के लिए.
Listen to us, we are not. Tell you a story, tell you a story, yeah, tell you a story of ancient times. And it's a glory, oh, listen to the story, yeah, listen to the story. Oh, सुनाते हैं तुमको कहानी अपनी जुबानी है अपनी जुबानी ऐसे बड़ी सी गणित ये पुरानी सुन लो कहानी है ये सुहानी
The story of Indian mathematics started about 5,000 years ago. Now let me tell you something about the Indus Valley civilization of Harappa, Mohenjo-daro, Lothal, Dholavir and many other cities. Do you know it gained its roots somewhere around 3000 BC, but it started declining around 1750 BC. Unfortunately, there is very limited information present about the great civilization. If we manage to crack the codes to these inscriptions, we might have some useful information.
Tamudu, note the point. Cracking the code of the inscription. A mystery. समझा क्या?
इसमें क्या राज छिपा है?
यही तो सवाल है. Who were those people and what was the cause of the decline of their civilization?
It looks like a lot of practice, floods, epidemics, or maybe a depression. Any which ways, there was a pause in the progress of mathematics after that. A long pause. The next traces of mathematics were found in the Vedic literature. Vedic literature went through various stages of development. Kamudu, chalo ginti shuru karo.
गिनती? Okay. 1, 2, 3, 4, 5.
ओ भाई साहब किधर जैसे ऋग्वेदा में की जाती है वैसे एका
1,
द्वि
2,
3
3,
अष्टा
8,
नवा
9,
दसा
10,
Now let's move to the larger numbers. Shata
100,
100 means 10 square. Now Sahasram,
I got this. 10 to the power 3.
Ayutham,
10 to the power 4,
Very good. Nyuta prayutar buddha, nirbudha samudra, madhya antah pararda.
10 to the power 12?
Bhaiya, utho, utho. Tamudu, an interesting way of representing numbers was world numerals. Fascination towards the world numerals led to mathematics being expressed beautifully in a poetic form.
Suna, mathematics was expressed in poetic form.
First of all, the subjective stuff. Now added to that, there's poetry.
Can't you see that this poetry enhances the beauty of mathematics?
चलो तमुड़ू वापस से गिनती शुरू करो.
एक बार फिर.
हाँ जी, और एक बार. Now tell me, how many moons does the earth have?
1.
Therefore, moon is equal to 1. Now, Jelly, tell me, how many eyes do we have?
2. Therefore, Nayana, eyes is equal to 2.
Agni,
3.
Veda or Yuga,
4.
Mahabhuta,
5.
Shastra,
6.
Rishi Muni,
7.
Matanga, that is elephant,
8.
Graha, planets,
9.
Avtara,
10.
Akash, Shunya.
0.
So now tell me, what is the word that can be given for 32?
I got this. Danta.
Shabash, you've got a Jnana Danta.
And it is functioning.
Dhanyavad.
Well, it is important to note that the numbers are codified into a reverse order. How about this number? Bhuta, Graha, Shastra.
Bhuta 5, Graha 9 and Shastra 6. So 596.
नहीं रे, reverse order में बोलने का.
Sorry. 695.
Good.
Tamudu, I just got a very great pet name for you. It just struck me, but only when you bunked the class. कहूँ क्या तुझे आकाश नैन वेदा?
Akash Nana Veda. Akash Sunya Nana Do Veda. 4. 420.
श्री 420.
बड़ी दीदी, आप हमें एक कहानी सुनाओ ना.
हाँ. Addition, subtraction, multiplication, division were used in Vedic Samhitas and Brahmanas in various contexts. But the operations were not defined in a formal way. An interesting and important source of mathematics after the Vedic period were the Sulba Sutras.
Sulba Sutra. थोड़ा मीनिंग बताओ.
Sulba means a rope or a cord.
And sutra means a rule.
Rope and rule in mathematics? No connection. Explain.
Will you relax? Well, Sulba Sutras means a collection of rules relating to the measurements only using the help of a rope.
Now look at these sets of numbers that the people found in Sulba Sutra.
These look like triplets.
This is so-called the Pythagoras theorem.
This might come as a surprise to many, but it's true that the Pythagoras theorem was known much before Pythagoras, and it was the Indians who actually discovered it at least 1,000 years before Pythagoras was born.
Oh, really? Who was the Indian mathematician? Well, it was the great Bodhayana. He formulated the theorem in 1000 BC.
Oh, look! I can already see a few Indian mathematicians here.
I think they are here to enlighten us about the contributions of our own scholars in the field of mathematics. So what are we waiting for? Let's welcome them.
Who do we have first, Arohi?
Here we have Brahmagupta.
Hello everyone, my name is Brahmagupta. I am a well-liked Indian mathematician and astronomer. I was born in 598 Christian era. I lived in Himalaya, Rajasthan. You can read my book, Brahmagupta Siddhanta, which is also So, learn mathematics with fun. Thank you.
That was a cute little Brahmagupta. Aravhi, do you know how many contributions Brahmagupta has made to mathematics?
No, Pranav, but here we have Ashmit throwing light on them.
Brahmagupta, the man who invented nothing, that is zero. He was an Indian mathematician and astronomer. Brahmagupta is the author of two books, the Brahmagupta Siddhartha and the Ekadhikena. The four basic operations, addition, subtraction, multiplication, and division, which are based on Hindu-Arabic numeral system, first appeared in Brahmagupta Siddhartha. Brahmagupta is the first to define the properties of the number zero, which was crucial for the future of mathematics and science. He discovered the formula to solve quadratic equations, the value of pi, almost accurately. With calculations, he indicated that the Earth is nearer to the Moon than the Sun. He found the formula to calculate the area of any four-sided figures whose corners touch the inside of a circle. He calculated the length of an year as 365 days, 6 hours, 12 minutes and 9 seconds. Brahmagupta talked about gravity and calculated that the Earth is a sphere and calculated its circumference to be around 36,000 kilometers. He also established rules for working with positive and negative numbers. Brahmagupta was remembered for his contribution to mathematics, and he was honored to be titled as his fellow scientist Ganesh Chakra Chudamani, which is translated to as the gem of circle of mathematics. Thank you.
Pranav, do you know that the four basic operations were in use even during the ancient times?
Four basic operations? I only know about the operations in theatre. What are basic operations?
Pranav, that's why I have called the grade 4 students to explain these to you.
Today, we are going to present Mathematics Day song. Add, subtract, multiply and divide. Add, subtract, multiply and divide. Addition is to combine. 1 plus 1 is 2. Add, subtract, multiply and divide. Add, subtract, multiply and divide. Subtraction is to take away. 2 minus 1 is 1. Add, subtract, multiply and divide. Add, subtract, multiply and divide. Multiplication makes more groups. 5 times 2 is 10. Add, subtract, multiply and divide. Add, subtract, multiply and divide. Division is to split apart. 12 divided by 3 is 4. Add, subtract, multiply and divide. Add, subtract, multiply and divide. Thank you.
That was a musical way of explaining the four operations. Do you know that it was during this time that geometry and symmetry also flourished? Here we have Sunishka of grade 7 showing the difference between symmetry and asymmetry.
a symmetric way of showing asymmetry.
Look who's on the stage. That's our cute little Aryabhatta. Welcome, sir. We are ready to hear it from you.
Hello everyone, National Science Day, greeting to all. I am Aryabhatta, India's first mathematician and astronomer. I was born in 478 CE at Ekadhikena Purvena. I discovered number zero, which can show nothing, but can be used as a placeholder. Thank you.
Arohi, do you know that Aryabhatta was also an astronomer from the classical age in Indian history and has also made contributions towards the magic number of Shunya, that is zero.
That was a substantial contribution. We now have students of grade 1 presenting a sketch on zero.
One day, a great mathematician called all the numbers for a meeting. All the numbers came for the meeting except zero. Where is zero? No one knew where he was. Dear numbers, please go and find zero. All the numbers started looking for zero. And after a long time, they found zero hiding behind a tree. Zero! Why didn't you come for the meeting? I didn't come because I have no value. No one respects me. No, Zero. Who said so? All numbers have value. Mathematician thought for a while and said with a smile, don't cry, Zero. Even you have value. Number 1, come and stand next to 0. Come, Zeros. Stand with me. Now everyone, tell me what is the number. Number 10. Dear Zero, please come and stand with me too. Now together we are number 20. Let me stand with 0. Now we are number 30. So 0, now you know your value. Yippee! Yippee! I have also value like other numbers. Thank you, sir, for making me understand my value. This story teaches us to accept others who are different from you, to respect and treat everyone fairly, and when you do this, your value also increases. Thank you. One day.
Zero, we do value you now and have understood your importance. Here we salute this valuable hero with a song.
Hi everybody, my name is Ekadhikena. I'm going to sing a song about zero. Zero was invented by Aryabhatta. Let me tell you about a number that comes just before 1. He always tells you just what you have. When you have none, zero the hero. It's the superhero number that always counts nothing, that's all, and is shaped like a ball.
That was a heroic performance. Akshani, do you know that by now mathematics had become a force to reckon with? It was during this time that Bhaskara too influenced mathematical thought. Here we have our young Acharya. Let's welcome him.
Namaste, I am Bhaskara. You can call me Acharya or Bhaskara. I was born in 1480 at Bijapur, Karnataka. I discovered that any number divided by 0 is infinity and also the sum of any number with infinity is infinity. My famous book is Dharma Ceremony. It is divided into 4 sections. I also worked on Pythagoras theorem and invented the value of pi. Thank you. I am the best. Namaste.
To know more about his contributions, let's call upon Parth of grade 6.
Hello everyone, I am Parth from 6th B DSC Attapur. As a maths day, today I am going to be sharing Bhaskaracharya's work. Today, the runes of Patna are a reminder of the quest for mathematical ideas in order to improve astronomical predictions. Astronomical discoveries faded with the destruction of Ujjain, but the tradition of mathematics is survived. Engineers assimilated the knowledge of trigonometry, geometry, and improved techniques to build forts, large buildings, water tanks, and new cities. The historic fort of the Agure, close to Patna, constructed right before Bhaskaracharya's birth, was an engineering marvel. The ruins of capital city of Vijayanagar Kingdom, Hampi, a World Heritage Site, speak in silence about excellence in engineering, rainwater harvesting, management system, roadways, marketplaces, city layout planning, and stone masonry. Gol Gumbad, a famous monument in Bijapur, the birthplace of Bhaskaracharya, attests to the innovative two whispers from one corner of the building get carried to the other. Madhava School of Mathematics flourished in Kerala. The mathematicians of the school refined Bhaskaracharya's idea on infinite series and the trigonometric tables. Visiting Jesuit scholars of the 16th century had access to these advancements. Historians of mathematics at the Manchester University.
One should never underestimate the contributions made by our Indian mathematicians, whether it was the concept of infinity or Reol's theorem. We were not behind the Western world conceptually. Here we have Hasini shedding the light to a few more contributions.
Concept of infinity. This concept of infinity is mentioned in the Veda as infinity is born from infinity, and when we take infinity from infinity, only infinity remains. Anything divided by 0 is infinity. This is the symbol of infinity. In those days, people used Ananta word in place of infinity. Ananta means endless or infinite. Example, in the picture, the snake on which Vishnu rested is called Ananta Sheshnag. According to Bhaskara, dividing larger number by smaller number of pieces gives larger number of pieces. Similarly, dividing 1 into pieces of 0 gives infinite pieces. Basic for calculus. In 12th century, Baudhayana documented Siddhanta Shiromani of all the mathematical study of continuous change. He also wrote about the preliminary concepts. But in those days, people give the credit to Godfrey Leibniz in 17th century, but Bhaskara described this 500 years ago. He also documented the Rolle's theorem in his book.
Geometry was one area that Bhaskara worked on apart from infinity. Let us enjoy a dance by Sai Shriya, adding a new angle to the dance form itself.
Acute angle triangles. Obtuse angle, an angle between 90° and 180°. Right angle, it always measures 90°. Acute angle, an angle between 0° and 90°. Straight angle, a straight angle always measures 180°. Reflex angle, an angle between 180° and 360°. Obtuse angle. Right angle. Obtuse angle. Acute angle. Two obtuse angles. An obtuse angle and an acute angle. Obtuse angle. Namaste.
That was an aesthetic performance by Shriya. Well, the 20th century saw one of the most famous Indian mathematicians of all times. The man who knew infinity, who shared numbers with a great affinity, carved his birthday into a magical square, made contributions that were in the world rare. He didn't mind the bruises caused by poverty and turned them into the marks of his scholarly curiosity. He is none other than Srinivasa Ramanujan, who made substantial contributions to mathematics. Surprisingly, today we have not one but two dynamic Ramanujans amongst us. Let's hear it from them.
Everyone, I am Srinivasa Ramanujan. Have you heard about me? Well, I made significant contributions to mathematical analysis, complex analysis, number theory, infinite series and continued fractions, hypergeometrical series, the Riemann series, the elliptic integrals, the theory of divergence series and the functional equations of zeta function. Including solutions to mathematical problems considered unsolvable. My game theory is purely based on intuition and natural talent and remains unrevealed to this day. I initially developed my own mathematical research in isolation. Later, I began postal correspondence with the English mathematician G.H.R.D. at the University of Cambridge. He regarded my work as extraordinary and compared my work with Euler and Jacobi. Also arranged for me to travel to Cambridge. During my short life, I compiled near 3,900 results, mostly identities and equations. The most popular ones are Ramanujan prime, the Ramanujan theta function, partition formulae, and mock theta function. These have opened entire new areas of my work and inspired a vast amount of further research. Further, my notebook containing summaries of published and unpublished research have been analyzed and studied for decades since my death as a new source of mathematical ideas. I became one of the youngest fellows of the Royal Society and one of only the second Indian member and the first Indian to be elected as a fellow of Trinity College, Cambridge. One of my most recent findings was infinite series of pi. This series forms the basis of many algorithms we use today. I gave several fascinating formulas to calculate the digits of pi in many unconventional ways. Aryabhatta described the mock theta function, which is now recognized as holomorphic parts of mass forms. Do you know the significance of 1729? Yes, it is known as the Ramanujan number. Sum of cubes of two numbers 10 and 9. Here 10 is cube, but 10 cube is 1000 and 9 cube is 729. It is 1729. Is it interesting? This is the smallest number that can be expressed in two different ways, as it is the sum of these two cubes. Interestingly, 1729 is a natural number following 1728 and proceeding 1730. Here, I bring interesting puzzles for you. This puzzle is known as finite nested radical. In 1911, I sent the right hand side of the following equation to a mathematical journal as a puzzle. If you are intimidated by this first side, don't be. I'll solve your puzzle in few seconds. X plus 1 whole square equal to x square plus 2x plus 1 equal to x into x plus 2 plus 1. Rearrange the terms to get x plus 1 whole square equal to 1 plus x into x plus 2. Now, if we substitute 2 and 3 and 4 for x, we get 3 square equal to 1 plus 2 into 4, comma, 4 square equal to 1 plus 3 into 5, comma, 5 square equal to 1 plus 4 into 6. Isn't it interesting? This is my second question puzzle where we use basic algebra to prove the famous golden ratio pi is equal to infinite, continued fraction shown below. And no need to be intimidated. The neat thing about the continued fraction on the right is that it is self-similar all the way to infinity. That means that you can start anywhere and get exactly same continued fraction as shown in the picture below. The continued fraction in the red box is exactly same as in the black box. Yes, as we say in the last month's column, as far as infinity is concerned, a part can be equal to whole. Based on the observed equality, can you set up an equation for the continued fraction and solve it with some elementary algebra to show that it is equal to the golden ratio? Note that this value 1 plus root 5 by 2 is contained in my far more elaborate result that Hardy said that I defeated him completely. Did you enjoy? In 1919, ill health compelled my return to India. My last letters to Hardy show my new mathematical ideas and theorems. My last notebook containing theorems. My last notebook containing discovery from the last year of my life caused great excitement among mathematicians when it was rediscovered in 1976. I was able to treat the footsteps of great mathematicians like Bhaskara and Aryabhatta, taking the legacy of India ahead. Thank you.
Those were some outstanding tricks and solutions to complex questions. Thank you, Ramanujan sir. Here we have Ibrahim showing us a few mathematical tricks.
Udva Tirbhaya is the general formula applicable to all cases of multiplication and also in the division of a large number by another large number. It means vertically and crosswise. Using vertically and crosswise multiplied by 5. Suppose you need 8 multiplied by 7. 8 is 2 below 10 and 7 is 3 below 10. Think of it like this. The answer is 56. How? You subtract 8 minus 3 or 7 minus 2. That is 5. The first figure of the answer. Now you multiply vertically. That is 2 multiplied by 3 equals 6. Now that's it. Here's the answer. Look how easy it is. See how far the numbers are below 10. Subtract one number's deficiency from the other number and multiply the deficiencies together. For example, 7 multiplied by 6 equals 42. Here's a carry. The 1 in the 12 can also work to make 3 into 4. Here's how to use vertically and crosswise for multiplying numbers close to 100. Suppose you want to multiply 88 by 98. Is that easy? Oh, not so easy. You might think. But with vertically crosswise, you can give the answer immediately using the same method as above. Both 88 and 98 are close to 100. 88 is 12 below 100 and 98 is 2 below 100. You can imagine the sum set out like this. 86 comes from subtracting crosswise, which is 88 minus 2, which is 86, or 98 minus 12, which is 86. You can subtract either way. You will get the same answer. And the 24 in the answer is just 12 multiplied by 2. So, 88 multiplied by 98 equals 8624.
Indian statistician who devised the Mahalanobis distance and was instrumental in formulating India's strategy for industrialization in second five-year plan. P.C. Mahalanobis is here to speak about himself. Welcome, sir.
Hello everyone, I am P.C. Mahalanobis. I am an Indian scientist. I am statistician. I was born on 29th June 1893 in West Bengal. I was also a member of First Planning Commission of Free India.
To speak more on his contributions, we have Sukrit of grade 6.
Good morning. I'm Sukrit Gupta from grade 6C. Let me tell you a little more about this not so well-known mathematician, P.C. Mahalanobis. Did you know why he is regarded as the father of Indian statistics? It is because of his instrumental contributions in formulating India's second five-year plan. He was the one who laid the blueprint for industrialization and development in India. He formed a group that was interested in statistics, which later expanded, and eventually the Indian Statistical Institute (ISI) was founded in 1932. In the next year, he launched Sankhya, the Indian Journal of Statistics. He also established the National Sample Survey in 1950 and set up the Central Statistical Organization to coordinate statistical activities. He became a member of the Planning Commission in 1955 and continued in that capacity till 1967. He also introduced innovative techniques for conducting large-scale sample surveys, calculated acreages and crop yields using the method of random sampling. He devised a statistical method called fractal graphical analysis used to compare socio-economic conditions of varied groups. He was honored with the Padma Bhushan in 1968 and was also conferred with many other international awards. He had also discovered and invented many other things than these. He passed away on the day before his birthday on 28 June 1972. His contributions and discoveries have been forever helpful for the nation to develop in the field of Indian statistics. Thank you.
What fun would it be if we could see a few tricks too?
Today I'm going to tell you about Ekadhikena Purvena. The sutra or formula Ekadhikena Purvena means by one more than the previous one. A quick way to square numbers that end in 5 by using the formula by one more than the one before. I didn't understand it clearly. Why not? Let's understand it with the help of an example. Here is an example. 75 into 75 is equal to 5625. As both the numbers end in 5, we can use the Ekadhikena Purvena formula. But how can we apply the formula? Let's check it out. The solution is 75 square is equal to 5625. 75 square means 75 multiplied by 75. The answer is in two parts, 56 and 25. The last part is always 25. The first part is the digit in the tens place, that is 7 multiplied by a number 1 more than 7, which is 8. So 7 multiplied by 8, which is 56, gives us the first part. So the 75 into 75, which is 5625. Here is another example. 32 into 38 is equal to 1216. This is tricky because we don't have 5 at last, but we have 2 and 8 in the units place, which add up to 10, and both numbers start with 3. So here apply the Ekadhikena Purvena method, that is 3 multiplied by 1 more than 3, that is 4. So 3 into 4 is equal to 12. So we get the first part of the answer. After that, multiply the last two digits of the numbers. That is 2 into 8, which gives us 16 to get the last part of the answer. Combine them and you will get your answer. That is 1216. Isn't it easy to solve these hard multiplication sums with Ekadhikena Purvena? Today I'm going.
I understood this trick completely. Have you heard of the term recreational mathematics? Now let's call upon our next mathematician, Mr. Kaprekar, a famous recreational mathematician who was surprisingly a school teacher too. He fused math with entertainment to concoct the right mix.
Suprabhatam to all. I am Dr. Kaprekar. My complete name is Dandapriya Ramchandra Kaprekar. I worked as a school teacher at Nashik. I love to play with decimals and integers, so I contributed to discovering decimals, and magic equals. According to me, 6174 is a magical number. It is also known as Kaprekar constant. Number 495 is also known as three-digit Kaprekar constant. Thank you.
Let's also see the contributions made by Kaprekar sir to mathematics. Why not enjoy another math trick too?
My name is Malika Sriyasha of grade 70, and today I am going to tell you about Dr. Kaprekar's constant. One of the major discovery of Dr. Kaprekar is the Kaprekar's constant, which is a magical number 6174. This 4-digit number is very special. Do you know why? Let's see why it is so special. First, let's choose a 4-digit number in which all the digits are different. I choose the number as 3524. You should not choose a number in which the digits are same. For example, 1111. Then you need to form a greater and smaller number out of that digits. I got the answer as 5432 minus 2345. You need to find the difference after forming the greater and smaller number. I got the difference as 3087. Again, you need to repeat the steps. So I got the greater number as 8730 minus 3078. If we find the difference, we got the difference as 8352. Now again we need to form a smaller and greater number out of these digits. I got the greater number as 8532 minus 2358, which is equal to the Kaprekar's constant 6174. That's why this number is called a special number. Again, if you form the greater and smaller number out of these digits, again you would get the answer as 6174. I hope that you all have understood why is this number so special. Thank you.
That was indeed interesting. Now we have our last mathematician on stage, Mrs. Shakuntala Devi, the holder of Guinness Book Record.
Hello everyone, I'm Shakuntala Devi. Actually, I was supposed to have a computer, but I could not make this cycle because human mind has more capabilities than a computer. But I still think I'm the best. Thank you.
Thank you, ma'am. Here is a clipping of interview the great Shakuntala Devi had with our DSCN last year.
Ladies and gentlemen, welcome to the last year show. And today we have amazingly calculative personality with us. Please put your hands together to welcome Miss Shakuntala Devi. Nobody challenges me. I challenge myself. Good morning everyone. I am Shakuntala Devi, the human computer, astrologer and author of many books. Miss Shakuntala, when did you realize that you were gifted with all these capabilities of calculation? Can you explain how do you make it possible at all? Okay, as I remember, I was 3 years old. I would do every calculation in my mind. I don't have any explanation for this. I think it is God's gift. If I ask you to multiply two 13-digit numbers, would you give me the answer promptly? Well, I wouldn't. Because I would first ask you, do you want me to start from right to left or left to right? Ma'am, you have an amazing sense of humor. When and why did people start calling you the human computer? As I remember, it was a live BBC session in London. The host asked me a question. I replied that the question is invalid, but nobody believed me. Then the host verified and found indeed the computer posted an invalid question. From then on, people started calling me the human computer. Ma'am, you're really genius. Can you share your perspective on mathematics? I will not just say that math is a simple concept. It is not just about adding, subtracting, multiplying or dividing. It is the greatest logic and only truth in the world. It is everywhere, in every symmetrical pattern, in the stacks of wildflowers, even in the rhythmic chirping of birds. We are surrounded by mathematics, and yet we fail to recognize it. I'm sorry to say, it is all kind of conditioning. True that, Mum. We are conditioned to believe that math is only numbers. My last question to you is, what is your dream for the future?
I want to set up an institute for poor children to realize their potential. It is for the same reason that my books focus on getting the younger generation interested in maths. Love mathematics for what it is, a way of life. Thank you, Mom. Namaste.
That was a wonderful interview. Mine was very witty and humorous at the same time. Can we also have a mathematical trick proposed by her?
Good morning, everyone. My name is Madhurima and I'm from 7C. Today, as part of Maths Day, I will be explaining two-digit multiplication trick of Shakuntala Devi. So let's get started. So there are some conditions and steps for doing the two-digit multiplication. Let's know the conditions. First one, sum of digits of the 10th place is equal to 10. Second one, digits of the unit places should be same numbers. Now, how to do this multiplication? Multiply those unit places and write the last two digits of the answer. Second step, multiply the 10th place and add the digit of the unit place. If all of these conditions and steps are fulfilled, then your answer will be fulfilled as well. So, let's take an example. Now, same we have to do 28 into 88. Here, first condition will read sum of the digits of the 10th place is equal to 10. So, sum of the digits of the 10th place. 10th place numbers are 2 and 8. Here. So, if you add these two numbers, you get 10. Now, second condition, digits of the unit places should be same numbers. Digits of the unit places 8 and 8 are same, so it is fulfilled. Now, let's go to the steps. First step, multiply the unit places and write the last two digits of the answer. So, multiply the unit places 8 and 8. If you multiply, you get 64. And these are the last two digits of the answer. Now, second step, multiply the 10th place and add the digit of the unit place. So, multiply the 10th place, 2 and 8, you get 16. Now, add the digit of the unit place, that is 8. So, 16 plus 8, that would be 24. So, answer is 2464. Thank you.
That was a time-saving multiplication trick. Oh, I see all the mathematicians back on the stage. What are they here for again? Are we going to witness a mathematical clash of the titans? I can already hear the thunder and lightning.
I am the Aryabhattas. I am the best. I am Ramanujan. I am the best. I am P.C. Mahalanobis. I am the best. I am Dr. Kaprekar. I am the best. I am Bhaskaracharya. I am the best. I am Shakuntala Devi. I am the best. I am Brahmagupta. I am the best. Dear mathematicians, each one of you is unique. Your contributions to the vast ocean of knowledge which flourished in India are priceless. Dignitary, it's time that we unite and ignite the flame of logical reasoning among the future generations. May our parents urge the future generations to take maths not as a subject but as a way of life. May they bring glory to our nation through their inventions, innovations, discoveries, and mathematical temperaments. Jai Hind! Jai
Thank you, Krishnakriti. That was some mathematical food for thought. Our mathematicians have truly inspired us to think logically and act calculatively. To top it all off, we have a little promise in the form of a song to take the legacy of mathematics forward. So, here goes the song.
గణితానికి ప్రేమికులం లక్కోజు రాగము శకుంతల వేగము
రక్కోజు రాగము పెంచెను విశ్వాసము శకుంతల వేగము అపురూప విజయము ఆ విశ్వాసము విజయాలను కొనసాగించే వారసులం గణిత శాస్త్ర సాధకులం పరిశోధకులం గణితానికి ప్రేమికులం వారసులం గణిత శాస్త్ర సాధకులం పరిశోధకులం గణితానికి ప్రేమికులం. ధన్యవాదాలు.
వారసులం గణిత శాస్త్ర సాధకులం పరిశోధకులం గణితానికి ప్రేమికులం వారసులం గణిత శాస్త్ర సాధకులం పరిశోధకులం గణితానికి ప్రేమికులం వారసులం గణిత శాస్త్ర సాధకులం పరిశోధకులం గణితానికి ప్రేమికులం. శ్రీధరుని సోదర శ్రీనివాస సాధన శ్రీధరుని సోదర సమీకరణ మూలము శ్రీనివాస సాధన ఇచ్చెను సందేశము ఆ శోధనను సాధనను కొనసాగించి వారసులం గణిత శాస్త్ర సాధకులం పరిశోధకులం గణితానికి ప్రేమికులం.
With that promise, we have come to the end of our program. But before we allow the audience to sit down and let the essence of the saga seep deep in, we would like to hear it from our dignitaries. May I invite our academic director, Shashi ma'am, to speak a few words.
What can I say? This became truly a saga of mathematics today. So, but I'm actually amazed at how much of compilation has been done by all of you, actually, the entire maths department. Such a lot of compilation across all the classes, so well choreographed, all the dances, and stitched so well. So the whole thing looked like a what I would call as a seamless presentation. Hearty congratulations, Praveen, Bharti, and the entire maths department. Very enlightening sessions. I truly appreciate the smaller kids, how well they have projected whatever they needed to. The interview with Shakuntala Devi was the highlight, in my opinion. It was so very well conducted and with so much of clarity and with confidence. Both of them did that. Actually, I wonder, I think these small children are far better than any of us put together, because they have that, what is called as that innate enthusiasm, innate zeal, and innate urge to please others, which we as adults have become so fossilized now that we are so very hesitant to do whatever comes so effortlessly to the others. Very well done. In fact, my special appreciation to all the little ones who came up with fantastic performances. And again, Praveen, very well done. In fact, because without a team effort and without the contribution of your team members, it wouldn't have been possible. I have seen how Bharti was flustered for the past 2-3 times that I have come with so much of coordination. It paid off very well, apart from the little glitches at the beginning of the session. Arohi, Akshayani, and Pranav did very well. In fact, it was very nice. I like that small skit, Tamudu, Bhai, Jita, all those things came out very well. Enjoyed every minute of it. I know all three of you were there in that. Very well done. And thank you so much for giving us such a nice program. Thank you.
Thank you, ma'am. Thank you, ma'am.
Thank you for your kind words, ma'am.
May I now request Principal Sir to share his views on National Mathematics Day.
Yes, Shashima mentioned it was an outstanding program. Congratulations to all of the mathematics department, Praveen sir, VP ma'am, and the entire department. Wonderful program. And you have brought alive the memories of quite a few mathematicians and enacted by the little ones to the elder ones. So that was something, nice. And also you have integrated dance, songs, and everything. So that was something amazing. Of course, messages have been already told. I would like to reiterate the same to others or those who are afraid of maths. First, Praveen sir mentioned that mathematics is not a subject, it should be a way of life. Please let us keep that in mind and let us carry on with that spirit. And also the board that we had, wonderful quotation is there. Mathematics gives us hope that every problem has a solution. Not only in mathematics, it should be in our life too. Yeah, that is a message we all need to keep, that every problem has a solution. Let us not be cowed down or shattered by any kind of problems that we face in our life. Every problem has a solution. So let us keep that in mind. And of course, program was, it's a Herculean task to, as Shashima mentioned, to compile such a, so many programs together. Bits together. It has gone amazingly well. I would like to congratulate all the team once again for the wonderful work. Praveen sir, BP ma'am, all the department, and also like to appreciate Pranav, Akshayani, and Arohi for taking us through the program. Wonderfully learned students. And my special appreciation to our ex-student Abhinav Singh for stepping in and taking us through. Thank you, Abhinav, for your timely help. We appreciate your joining us. Thank you so much. So all the programs, as Shashima mentioned, that Shakuntala Devi's interview was the icing on the cake, I should say that. So it was wonderful. All other programs also were excellent. So once again, I wish all the maths department and all the students also who are part of the program and the teachers who trained them, parents for their help for making this day a successful one. Once again, I wish all of you a very happy Mathematics Day. Let us find a solution for all our problems in our life and also in mathematics. Thank you. God bless.
Thank you, sir.
May I now invite Rashmi ma'am to give her views?
I think ma'am is not there, children. You can carry on.
Okay. Before we draw the curtains down on today's program, I would like to extend my heartfelt gratitude to our dignitaries Rama ma'am, Shashi ma'am, Reshmi ma'am, Principal Augustine sir, Vice Principal Bharti ma'am, Headmistress Lakshmi ma'am, coordinators CG ma'am and Malti ma'am, Vandana ma'am and her team of teachers, and Farzana ma'am and her team of teachers for their amazing videos. HODs with a special mention of HOD Math Praveen sir for his immense support. Teachers, parents, and dear friends who have not only been a wonderful audience but also displayed their dedication in making this program a huge success. Thank you, Jyoti ma'am, for the aesthetically made PPT and for compiling all the videos effortlessly. Thank you, Raju sir, for painstakingly shooting all the videos and covering the event today. We thank Vandana Singh ma'am for the beautiful invite and Sujana ma'am for the backdrop. Thank you, Veena ma'am, for live streaming the event. Thank you, Varsha ma'am, for welcoming the guests. Thank you, dear math teachers, for motivating us students to come up with creative videos. Thank you all once again. May I request all to rise for the national anthem.